Welcome, curious minds, to another deep dive. Imagine a microscopic mastermind capable of shutting down your digestive system, then turning itself into this, well, almost indestructible fortress to survive out in the wild for months. Sounds like sci-fi, right? But it isn't, it's Giardia. And today we're really peeling back the layers on this remarkably effective and, frankly, pretty irritating parasite. You've probably heard of it, I imagine, especially if you love the outdoors or, travel a fair bit. It's a truly global issue, affects over 1 million people annually just in the U.S., particularly where sanitation might be, well, a challenge.
Indeed. Yeah, our mission today is really to pull back the curtain on this pervasive organism, Giardia. It's a single-cell parasite, as you said, and it can cause quite a disruption in your gut. We'll uncover its sneaky life cycle, the very unpleasant symptoms it causes, also the advanced ways we now diagnose and treat it, and maybe most importantly, how you can prevent it. Get ready for some, I think, surprising insights and some practical knowledge that could genuinely help you out,
Yeah.
in the wild or even just in daily life.
Okay, let's unpack this microscopic mystery then. So, what exactly is Giardia at its core? I mean, how does such a tiny organism manage to cause so much widespread trouble? It's truly fascinating when you look at its strategy, its complex way of surviving and infecting.
It really is. And what's truly ingenious here is that Giardia has these two distinct forms. Each one has a crucial, almost you could say contradictory role in its life cycle. It's like it acts like a stealth operative first, and then it transforms into this incredibly resilient traveler. So first you encounter the trophozoite, that's the active
Don't
invader.
pick one, okay.
Yeah, visually it's kind of pear-shaped, quite small, about 12-15 by 5-9 micrometers, tiny. It's equipped with two nuclei and get this, 4 pairs of these whip-like flagella. That's how it moves around purposefully. But maybe its most crucial feature for infection is a ventral sucking disc that lets it latch directly onto your intestinal lining.
Wow, a sucking disc. So that's literally how it sets up its base camp in our gut. That's quite a powerful image.
Precisely. Exactly. This trophozoite, this is the form you'll find actively moving around, motile, and rapidly replicating in the host's small intestine. It multiplies through a process called binary fission, just splits in two, again and again. But here's the catch for the trophozoite, outside the host. It's quite vulnerable. It just can't survive for long. It dies off pretty quickly. Its metabolism is incredibly active, supporting all that intense growth and replication. And this is reflected in its diverse and rich transcriptome. Think of it like a vast, busy library of active genetic instructions, constantly churning out proteins needed for its fast growth and division.
Okay, so that's the active invader, the one causing all the immediate trouble inside. But what about its counterpart, the resilient traveler you mentioned, the one designed for the long haul?
Ah, right. That would be the cyst. Now, this form is different. It's oval-shaped, a bit smaller, maybe around 12 by 8 micrometers. And it's truly remarkable because it's protected by this smooth, incredibly hard wall, makes it exceptionally tough. Inside, it's like a little compact survival kit. It contains 4 nuclei and the structures needed for 2 future trophozoites. Essentially, it's pre-packed for its next adventure, its next host.
Pre-packed, I like that.
Yeah, and its metabolic activity, significantly lower than the trophozoites. It's in a highly dormant, very energy-saving state.
And here's where it gets really interesting, almost like its secret weapon, isn't it? The fact that these tiny cysts can survive for months out there in the environment. That explains why Giardiasis is such a persistent problem, why prevention is such a challenge, right? They're basically little time capsules of infection, just waiting.
That's a perfect way to put it. Time capsules of infection.
And I recall reading something about how they manage this incredible dormancy. They don't have typical mitochondria. They have these simplified versions called mitosomes instead. Could you maybe elaborate a bit on how those play a role in their resilience and saving energy?
That's a fantastic point.
Yeah.
Absolutely. So the cyst is the environmentally resistant dormant stage. It's specifically designed for spreading between hosts. And it truly can survive for months in harsh conditions, think cold water, on surfaces, just patiently waiting for a new host. This is the infective form that you or another host ingests, usually from something contaminated with feces. And you're spot on about the mitosomes. They're fascinating. Yeah, while we have complex mitochondria churning out energy, Giardia's mitosomes are like, well, minimalist powerhouses. They don't generate ATP, energy currency, in quite the same way. But they're involved in vital processes like iron-sulfur cluster biosynthesis, things that are essential even for its dormant survival. It lets it maintain viability with minimal energy use until it finds a new host. And its transcriptome, its active genes, much smaller, less diverse than the trophozoites, perfectly reflects that protected, dormant, waiting state.
And here's another truly sneaky detail I read about the trophozoite once it's active in the gut. Apparently, Giardia can't make its own lipids, things like cholesterol, which are crucial for building cell membranes. So instead, it's a master parasite at stealing cholesterol from its host, from us.
That's exactly right. It's a biochemical thief.
It actively siphons off our body's essential building blocks, which must be a key part of how it colonizes the gut so well and messes up our own absorption.
Absolutely key. It integrates host lipids directly into its own membranes.
Yeah.
Very efficient, very parasitic.
So, okay, once these microscopic hitchhikers have successfully attached, started stealing cholesterol, and set up shop, what does it actually feel like for the person who's infected? What are the common symptoms you, our listener, might experience?
Right, connecting this to the bigger picture. The symptoms are primarily gastrointestinal. Makes sense, given where it lives. And understanding why they occur helps explain their severity and why they can sometimes linger. The most common symptoms you'll likely encounter are, well, diarrhea, often described as fatty or steatorrhea, and pretty foul-smelling. You'll also very likely experience significant bloating, uncomfortable stomach cramps, nausea, and potentially dehydration too, from all that fluid loss through the diarrhea.
Ugh, that sounds incredibly unpleasant, debilitating even. But you mentioned understanding why these symptoms happen, that it's more than just irritation. What's the actual mechanism? What's going on inside the gut?
Yeah, the primary culprit is malabsorption. It fundamentally interferes with your ability to absorb nutrients. When those trophozoites attach to the small intestine lining using their sucking discs, they cause physical damage and atrophy to the intestinal microvilli.
The microvilli, those are the tiny finger-like projections, right? The ones that increase surface area.
Exactly. Think of your intestinal lining as being covered in this plush, velvety carpet. Those are the microvilli absorbing nutrients. Giardia comes along and essentially flattens them, damages them. This significantly reduces the surface area available for nutrient uptake. It's like turning that luxurious velvet carpet into a flat, smooth, much less efficient surface.
Wow. So it's not just an irritation, it's like a microscopic demolition crew, actively flattening the very structures we rely on for nutrition. And I imagine that physical damage is a major reason why symptoms can be so persistent sometimes.
Precisely. And that distinctive fatty, foul-smelling diarrhea, the steatorrhea, that happens specifically because your small intestine can't properly absorb fats anymore. These unabsorbed fats just stay in the gut and are then passed out in the stool. Makes it greasy and gives it that characteristic odor. Plus, the parasite actively reduces the expression of crucial brush border enzymes.
Like lactase.
Like lactase, exactly.
Yeah.
Enzymes vital for breaking down carbohydrates and fats. So this further impairs digestion and absorption. It can even lead to temporary or, in some cases, prolonged lactose intolerance. Even after the infection itself is cleared, that sensitivity can stick around for a while.
That's rough. So, okay, someone suspects they have Giardiasis, all those lovely symptoms. How do doctors actually confirm the diagnosis? What are the tools in their arsenal to catch this microscopic culprit, especially since it isn't always, visibly present?
That's a really important question. Identifying a microscopic foe that kind of hides and sheds intermittently, it requires specific methods. And the diagnostic approach has actually become quite effective, combining traditional and more modern techniques. The sort of gold standard for diagnosis is still stool microscopy, but combined with a direct fluorescent antibody test, or DFA.
DFA, how does that work?
Well, it involves examining stool samples under a microscope, looking for both the cysts and the trophozoites. But the DFA part enhances both the sensitivity and specificity compared to just looking under a regular microscope. It uses antibodies tagged with a fluorescent dye. These antibodies specifically bind only to Giardia. So under a special fluorescent microscope, the parasites literally light up. Makes it much easier, more reliable to spot.
Okay, so they're not just looking for a shape. They're making the parasite actually glow to find it more reliably. That definitely improves the chances. What about tests that give quicker answers, though? Sometimes you need to know fast.
Absolutely. For rapid and accurate screening, we have fecal antigen detection methods. Things like ELISA, that's enzyme-linked immunosorbent assay, and other rapid antigen tests. These are incredibly valuable. They work by detecting specific proteins or chemical signatures, the antigens that are shed by the Giardia parasite into your stool. It's kind of like finding a unique chemical fingerprint left behind by the culprit.
Like forensic science for parasites.
Exactly. And these tests can provide results very quickly, often in just 10 to 15 minutes. Plus, they boast really high sensitivity and specificity, so they're accurate. That makes them a preferred tool for quick screening in many clinical settings.
That's great for getting fast results, but what if a case is particularly tricky? Or if you needed like maximum precision, what's the ultimate confirmation?
Right, for molecular confirmation, the top tier is polymerase chain reaction, or PCR. This is a highly advanced molecular test. It detects Giardia's unique DNA right there in the stool sample. It's incredibly sensitive and specific because it can find even a tiny fragment of the parasite's genetic material
Ah,
and then amplify it, essentially making millions of copies until it's easily detectable. It's like finding that needle in a haystack by making the needle suddenly enormous and easy to see.
that's amazing
It
technology.
is, though it can be more time-consuming and potentially a bit costlier than the antigen tests. But for accuracy, it's top tier. And one more thing, to enhance detection in routine labs, especially if parasite numbers might be low, they often use fecal concentration techniques,
Right.
like formalin ether concentration. These basically spin down the sample, helping to concentrate any cysts that are present before looking under the microscope. Further improves sensitivity.
So we've got this whole range of tools then, from making the parasite light up to detecting its chemical signature to amplifying its very genetic fingerprint. It really is a testament to how science helps us pinpoint these invisible invaders, even when they're playing hide and seek. And I imagine sometimes they might need to try a few different approaches, especially since, as you said, Giardia might not always be shedding at constant levels.
You're absolutely right on the mark there. In clinical practice, yeah, antigen tests and DFA microscopy are common for that rapid screening because they're fast and accurate. But it's crucial to remember that sometimes multiple stool samples collected over several days might be needed. This increases the chances of detection precisely because of that intermittent shedding of cysts or trophozoites you mentioned. The parasite doesn't always show up consistently in every single sample. It's a bit like searching for a shy creature that only pops out now and then.
Makes sense. Okay, so now, with a clear diagnosis hopefully in hand, what's the game plan? How do we get rid of this unwelcome guest? Are there effective treatments, and how do they actually work to clear the infection?
Fortunately, yes, we do have effective antiparasitic medications that can clear Giardiasis. The strategies for fighting back are quite effective, and actually, an interesting comparison emerges between the primary options, especially when you think about the patient experience and, importantly, adherence actually taking the medicine. One of the leading treatments is a drug called tinidazole.
Tinidazole.
Okay,
Yeah.
this drug is generally considered to be more effective, actually, than metronidazole, which is another common treatment you might hear about.
More effective is a strong claim.
Yeah.
What makes tinidazole stand out, especially for, patient convenience?
Well, the key benefit, and it's a significant one for convenience and making sure people complete the treatment, is its single-dose administration. Think about it. Just one pill versus taking medication for several days.
Oh, huge difference.
Yeah, massive. A big Cochrane review back in 2006 and other research since then actually found a higher clinical cure rate with just a single dose of tinidazole compared to metronidazole's typical multi-day course. And that single-dose regimen, it significantly improves patient adherence. People are just far more likely to take one dose correctly than remember to take pills multiple times a day for 3 to 5 days. So that often leads to better overall eradication rates in the real world.
Wow. So literally a single pill could potentially be enough to knock out this persistent parasite. That's incredible for patient convenience, like you said, and just making sure people actually complete their treatment.
Yeah.
What about metronidazole then, the trusted alternative you mentioned?
Right, metronidazole. It is a widely used and effective alternative. It's been a trusted treatment for Giardia for a long time. However, it typically requires that 3 to 5 day course of treatment, unlike the single dose of tinidazole. Now, both drugs generally achieve pretty impressive cure rates, usually somewhere around 85–90%, and they share similar, usually mild side effects, things like a metallic taste in the mouth, maybe some nausea, occasional vomiting. So while both are effective tools, tinidazole definitely offers that significant convenience advantage, which, as we said, often translates to higher success rates simply because people are more likely to take it correctly.
Okay, that makes a lot of sense. Which brings us, I think, to perhaps the most important part for you, our listener. How do we avoid getting Giardiasis in the first place? What are the practical steps we can all take to protect ourselves from this remarkably resilient parasite?
Yeah, absolutely crucial. If we connect this back to the bigger picture, prevention really revolves around two main things: maintaining impeccable hygiene and, crucially, being extremely mindful of what you drink. Knowing how incredibly resilient those Giardia cysts are, what are our best defenses against such a tenacious opponent? Well, your primary defense, number one, has got to be water safety. You absolutely must stress avoiding direct consumption of water from lakes, rivers, springs, ponds, streams, basically any untreated surface water, unless it has been properly treated. This is such a common and often deceptively dangerous source of Giardia.
Right, it's those crystal clear, pristine-looking mountain streams that can be the most deceptive, isn't it? So if you're out in nature hiking, camping, what's the absolute safest bet? No more nature's refreshing beverage jokes on a hike then, eh?
Huh. Only if you've brought your portable water treatment plant with you. It's surprising how many seasoned adventurers, people who should know better, still get caught out by that beautiful, clear, but potentially contaminated stream. For absolute safety, boiling water is highly effective. Simple, but it works. You need to bring it to a rolling boil for at least 1 full minute. Or, if you're at higher altitude, say above 6,500 feet, make it 3 minutes just to be safe. That effectively kills Giardia cysts, absolutely critical for camping, hiking, or any travel where water quality is uncertain.
Okay, boiling is king. What about filters?
Yes, proper filtration is another excellent method, but you need the right filter. You should use certified water filters specifically designed to remove Giardia cysts. Look for filters that meet NSFA NSI standard 53 or 58, or check the packaging for an absolute pore size of 1 micrometer or smaller. The good news here is that Giardia cysts are actually larger than many bacteria and viruses, which makes filtration a really viable option for removing them.
Okay, 1 micrometer or smaller, noted. What about those chemical treatments? Like iodine tablets or chlorine drops? I see those used a lot for camping too.
Right, chemical disinfection.
Mhm.
Using agents like chlorine or iodine, they can be used, but there's a really important caveat here. Giardia cysts are known to be quite resistant to some disinfectants, especially chlorine, when used alone, particularly in cold water. Therefore, the recommendation is that filtration should always come first. If you choose to use chemical treatment, it should really be after you've filtered the water, kind of as an extra layer of protection, not as your only solution against Giardia.
Filter first, then maybe chemicals. Got it.
Exactly. And when traveling, if there's any doubt, always opt for commercially bottled water. Make sure it's been treated by reverse osmosis, distillation, or filtered through an appropriate micron filter. And importantly, try really hard not to swallow water while swimming or playing in pools, lakes, rivers, or other freshwater bodies. Giardia can easily spread this way too, even sometimes in treated swimming pools if contamination occurs.
Right. So essentially, the takeaway for water is assume the worst unless you absolutely know it's been properly treated. Boil it, filter it correctly, or buy it bottled. And good old-fashioned hand washing. Still a superpower, I take it.
It absolutely is. Cannot overstate it. Personal hygiene is your second major line of defense. Really emphasize thorough hand washing with soap and water scrub for at least 20 seconds, especially after using the toilet, changing diapers, or handling animals. This significantly reduces the risk of accidentally ingesting cysts that might be on your hands. And then on a larger scale, of course, maintaining proper infrastructure and public health measures are crucial. For people with private wells, make sure they are well constructed and properly maintained to prevent contamination from surface water runoff. And always, always follow local boil water advisories and other public health instructions if there's ever a waterborne disease outbreak in your area.
Makes sense. It's a combination of personal vigilance and community-level safety nets.
Exactly. And maybe one less obvious point, but an important insight. Giardia's presence in water sources often serves as an environmental indicator. It frequently signals broader issues with fecal contamination in that water body. This affects not just humans, obviously, but wildlife too, creating this complex ecosystem challenge that really extends far beyond just a single person getting sick.
That's a really interesting perspective. It's a canary in the coal mine for water quality.
In a way, yes. So what does this all mean? Our deep dive into Giardiasis today reveals this common, incredibly resilient parasite that, yes, causes significant discomfort and gut sabotage. But it's entirely treatable and, importantly, largely preventable. Understanding its sneaky two-stage life cycle, how it attacks our gut, and knowing these simple yet effective prevention strategies, especially around water and hygiene, really empowers us to protect ourselves and our communities, both at home and when we're out on adventures.
That's right. From that pear-shaped active trophozoite literally stealing our vital nutrients inside, to that incredibly tough cyst that can survive for months in harsh environments. Giardia is definitely a master of survival. But with our hopefully newfound knowledge about safe water practices, diligent hygiene, and effective treatments like that convenient single-dose tinidazole, we can minimize its impact and protect ourselves from its microscopic mischief. We really hope this deep dive has given you a clearer picture of Giardiasis and equipped you with some valuable practical insights. Next time you're gazing at that beautiful, cool, clear stream on a hike, maybe pause, and you'll know exactly what questions to ask before taking a sip. Or better yet, just get your filter or stove out.
Good call. Until our next deep dive, keep learning, keep exploring, and definitely stay curious about the often unseen world around you.